take investment X and investment Y. We've been given the cost of each of these investments. Okay, investment X cost is 500,000. Let me put this as zeros. 500,000. Investment Y, the cost is 800,000. Right. So if we invest in X, okay, these are the forecasted returns we're going to get, okay, from this investment. In year one, we're going to get 250,000. Okay. Year two, 100,000. Year three, 50,000. Year four, 40,000. Okay. Then we also have this information here which says scrap value in year four. So it means this machine, which is model X, we can sell it for 30,000 after 4 years. Okay. That's what we mean here, the scrap value. Okay. So we're going to see which machine we should invest in using the net present value technique. Okay, should we invest in X or should we invest in Y? Okay, for investment Y, as we can see here, the cost 800,000. In year one, you get 400,000. Year two, 550,000. Year three, 600,000. Year four, 500,000. And after 4 years, we can sell that model for 200,000. So we're going to use the net present value technique, okay, where we're going to discount this money which we're going to receive in the future. Okay, all of this, they are forecasts. Okay, this is what we expect to get. So this money that we're going to be receiving in the future, we're going to convert it into today's value. Okay, if you remember the formula for getting a present value equals future value multiplied by 1 plus r the power negative t. Okay. So all this money here, we're going to convert it into today's value. Okay. And then we'll compare it against this cost. Okay. When we compare it against the cost to see were the returns greater than the cost, or was the cost more than the return? And this is the decision rule for the net present value technique. Okay. If your net present value is greater than 0, it means when you subtract the costs and the returns, you get a positive value. Then you accept the project. That a positive net present value represents like a profit. Okay. If your net present value is 0, okay, it means you have broken even and you don't need to accept the project. If your net present value is less than 0, meaning the cost outweighs the returns or the profits from this investment, then that represents a loss, so you need to reject the project. Alright, so you can do this in a table form. Okay, we can solve this in a table form like this. Where you're going to have the year, okay, cash flow, and then you have the discount factor, and then you have the present value. Now colleagues, remember, all we're doing, we're just doing this same, applying this same formula here, this formula here, okay? Where there's cash flow, think of this as the future value. Where there's discount factor, we're going to put, this is where you have the 1 plus r to the power negative t. Okay? When you multiply these two, this is what's going to give you your present value here. So don't get confused and say, oh no, with this table something new is happening. No. Right? If you're not comfortable with the table, you can just use the formula and apply it on each of these individually, then add them up. Okay. So our discount rate is going to be our cost of capital. Okay, we did write that down. So I say the cost of capital for this question is 12%. Colleagues, remember the cost of capital is the cost of financing. Okay, cost of financing. Okay, as a company, you can get financing through debt or through equity. Now, that financing is not going to be for free. There's going to be a cost attached to it. So if you get financing through debt, the cost is that interest payment. Okay, the cost of borrowing. You get financing through equity, then your cost is going to be that dividend you'll be paying. Colleagues, please remember that sentence which I've just said there, because we're going to be applying it when we reach weighted average cost of capital. Okay. The cost of debt financing is the interest payments that you pay. The cost of equity financing when you sell shares. Okay. Remember, you have to pay the shareholders the dividends. Okay. So each source of financing has got a cost attached to it. So in this case here, probably to get machine X or machine Z, probably we've got a loan. Okay, and they've told us the loan, the interest rate is 12%. Okay, so our cost of capital, this question is going to be 12%. Okay, cost of capital, CC, 12%. This is going to be used as our discount rate. Okay, colleagues? Yes. So we're going to begin with year 0. Alright. Year 0 represents the first day of year 1. This is when you are purchasing the machine X. Okay, so we're going to say the cash flow here, we're going to put negative 500,000 here. Okay, negative 500,000. Okay. Discount factor here. Alright. We're going to put 1.12 to the power, since it's year 0, so we're going to put it to the power negative 0. Colleagues, are we okay with this? Consumer friendly? Any questions? Okay. So anything raised to the power 0 is always 1. Okay. So 1.12 to the power 0 is 1. 1 times negative 500, present value negative 500. Any questions on this? Okay, year 1, cash flow, we're getting 250, so a positive amount here. Alright, now this is where we can go to our table. Okay, colleagues, our present value table. Okay, our discount rate is 12%. Okay, so let me get it side. Make sure we're using the correct table. Yes, so this is the present value table. Okay, our discount rate is 12%. So we are going to cut me here. Okay, on 12%. Alright. Then on the years where you see this N, okay, number of periods. So this is year 1 here. Okay. So where the year and the discount rate intersect, that is your present value. Okay. So let me bring it to this side here. So here 1.12 to the power negative 1, you get 0.893. Those with calculators, 250 times 0.893, 250 times 0.893. Or let me take it to Excel to make life easier. Okay, so yes, 1.12 to the power negative 1, 0.893. Okay, so our present value, we're going to say 250 times 0.893. We get 223.25. Any questions before I move further? Okay, so we can see year 2, okay, discount rate at 12%. Yes.
Mr. Mara, I just wanted to find out the percentage is always given in the question.
Always. Okay, always.
Thank you.
Hello, sir.
Yes.
On year 0, is it always that it's negative? The actual capital, the starting capital.
For all the years, it's going to be negative.
There's the negative and the 0.
Yes, and to the
Yeah, 0 always there's a negative.
Yes, always.
Okay, alright.
Even here, it's supposed to be to the power negative 1, power negative 2. Okay. Okay, yes. So for year 2, Yes, discount factor 0.797. Year 3, discount factor 0.712. Okay. Year 4, 0.636. Okay, 0.636. Okay. Even for the scrap value, use year 4, don't put year 5. Okay. The assumption is you will sell it at the end of year 4. Okay. So if we wanted, we could have added this 40 plus 30, we get a 70, and then just multiply it by that. Okay, or you can also just do it like this. The discount factor, same for the scrap value, 0.636. Okay, colleagues? So you just multiply cash flow times discount factor, 100 times this, 50 times 0.712. Okay. 40 times 0.636. Okay. 30 times 0.636. Okay, colleagues. All this money that is coming in the future, these are its values today. Okay. So now we're going to get the net present value. Okay. So you just add negative 500 plus 223.25 plus 79.7 plus 35.6 plus 25.44 plus 19.08, and you get negative 116.93. Meaning this cost outweighs these returns. Okay. The cost of buying this equipment outweighs the money that this equipment is going to bring for you. Okay. Yes. The other way you could have done it, you can just total up all the returns first. Total returns, total present value. Okay. This is the total return you are getting. Okay. This is the total money that you're going to get. So you are comparing it against this 500, and you can see it's less than the 500. Okay. So since our net present value is negative, it's less than 0. It's less than 0. So we reject the project. Okay. We reject to buy X. Any questions?
Okay, sir. I'm trying to follow you. Now, I think I'm just a bit behind on how to pick my percentage and other things on the same table. Maybe you can try to...
How to pick the percentage, or how to locate it? You mean how to locate it?
Yes, exactly. I think how to locate it. Yes, thank you.
Okay, once you come on your table, first you look. So
yes.
Once you confirm it's the present value table, the percentages are on the top row.
Okay.
Then the time period is here. Okay, this column.
Okay.
Yes. So as we are using 12%, as you can see here.
Yes.
So for year 1, so where these two they intersect, that's the value you use. Okay.
Oh, okay.
Yes, as you can see, for year 1 and 12% they intersect at 0.93.
Okay.
Year 4 and 12% they intersect where? 0.636.
Oh, okay.
Yes. Just remember, every table you use in university, every table you're going to use in university, it's the same concept. Where two things intersect, that's the value you are getting.
Oh, okay. Thank you so much.
Yes. Any questions? So project X, we do not get it because the money it's bringing us is less than what it costed. Okay? Yes. So colleagues, can I leave you to do for investment Y?
Just, I think I don't know. Hello?
Yes,